If you type clouds and climate change into Google, the first thing that comes up is from NASA climatekids.gov. And it says this on Google: just as clouds affect climate, changes in the climate affect clouds. Their relationship is known as cloud climate feedback. It's one of the most challenging research areas in climate science. Climate scientists predict that as Earth's climate warms, there will also be fewer clouds to cool it down. So clouds are one of the biggest topics in climate science currently. It's one of the reasons why there isn't an established consensus on how much global warming is currently happening or is predicted to happen. And it represents one of the most challenging areas for modeling in climate science, and there's all sorts of inaccuracies littered throughout the academic literature in the past on this as well. And climate scientists saying, I mean, this is just what this kid's website on NASA says: climate scientists predicts that as Earth's climate warms, there will also be fewer clouds to cool it down. I mean, just straight off the bat, that doesn't make much sense from a scientific standpoint, because if there's going to be fewer clouds, surely there would be less evaporation of the oceans. And I don't know why that would be going on if it warms up. Surely, if the temperature is getting warmer, there'll be more evaporation from the ocean and hence more clouds, if anything. It's just like what I got taught at school about the climate change issue, that there'll be more arid areas opening up around the world as a result of climate change. However, the reverse seems to have happened, that arid areas have been rolled back, semi-arid areas are rolling back, that there's been this expansion of green space around the world, driven in part by human interventions, but also driven in part by increases of CO2 in the atmosphere. That CO2 in the atmosphere, of course, is plant food, is food for plant life, aids and assists agriculture. So you get these increases in agricultural yields resulting as a result of CO2 emissions. And you also get just the expansion of green space without human intervention as well. And this has been reported around the globe in India, China, um, regions in sub-Saharan Africa, also becoming greener, it seems, as a result of CO2 emissions. So what we have to kind of navigate with climate science is this false consensus, for one thing. I think we have to muster within ourselves the courage and the perspicacity of vision to be able to see the argument from all different perspectives, to be able to really engage with the research literature. And the research literature, particularly on cloud coverage and climate modeling, is far from incomplete. Studies have overestimated, for instance, the amount of rainfall that certain regions around the globe will be having, therefore underestimating the amount of rainy cloud cover, overestimating the amount of thin, high altitude clouds versus lower water vapor dominated clouds that reflect huge amounts of incoming radiation. I'm pretty certain also that clouds that are formed of ice crystals high in the atmosphere will also be reflecting incoming solar radiation to some extent, to quite a great extent probably, as opposed to merely reflecting light coming from the surface back down towards the surface. So yeah, cloud coverage. And this is something that NASA, not NASA, the National Oceanographic and Atmospheric Administration, NOAA, in the United States, they report very honestly and upfrontly about this, that there aren't good estimates for how much cloud coverage there is, nor do we know accurately what the impact of clouds on the climate is yet. And as of 2024, this year, I've been reading research published on Nature that seems to chime with this opinion, that there have been overestimates in the CMIP6 climate models and the CMIP5 climate models, going back to CMIP3 climate models. And this sort of stuff just can't keep continuing. We can't keep continuing to assert that we have consensus on climate change when consensus is anything but valid. It's just a load of people in academic departments, I'm afraid to say, just singing from the same hymn sheet because they don't want to lose grant funding and they want to keep their jobs. And they also don't want to undergo things like social ostracism as a result of believing the truth, probably, about climate change, that this 1.5 degrees or so of warming, which may or may not have happened, and that we may be modeling global temperatures inaccurately, and that could be all that's going on. So I'll give some links in the description to this now, And this is some quite recent research that's come out, a couple of articles from Nature, a few other bits and pieces I'll think about. But yeah, one of the biggest problems that exists in current climate science is the modeling of clouds. And obviously, if you can't model cloud coverage, you can't really model climate change. You can't really have any estimates for how much warmer the temperature is going to be or what the temperature is at the moment, even since clouds obviously cool down surface temperature. They have a negative effect on the surface temperature, generally speaking, which is just obvious. If you go outside on a cloudy day, it's likely to be quite a bit colder than it is on a sunny day with no clouds, which needs to be taken into consideration. I was really surprised to see this on this kids NASA website. Um, just as clouds affect climate changes and the climate affect clouds, the relationship is known as climate-cloud feedback. It's one of the most challenging research areas in climate science. Climate scientists predict that as climate warms, there will also be fewer clouds to cool it down. But there must be more clouds because there's more evaporation from the seas. Come on. I mean, when did that escape the attention of scientists and, Earth scientists in particular? Surely you know that as temperatures increase, there's more evaporation from the seas, hence more water vapor in the air, hence more clouds. So this is something else. I don't think any amount of global warming would affect global temperature because you increase the warming. There's more evaporation from the seas, more cloud coverage in the air. The greater the cloud coverage in the air, the more sunlight gets reflected from the clouds back into space and creates a cooling effect, which just balances the whole thing out. This is nonsense, utter ridiculousness. That is just an outright bit of stupidity from science. Um, Advertised by, of all people, NASA on their dumbed down, I assume, climate change website for children. But whatever. I'll give a link to that in the description as well, and a link to a couple of papers also that detail this issue of climate change in clouds, or an article that links to the paper. And you can find other papers on the Nature website from there if you're so inclined. But thank you everyone for watching. This is a brief rundown of not just what I think about cloud coverage and climate change, but what lots of scientists, including the Nobel laureate John Clouds, I think, have reiterated about the state of our knowledge when it comes to cloud cover. So not entirely unevidenced, not entirely without precedence in opinion. By no means, my own personal hypothesis on climate change in clouds. But yeah, just for a bit more of an honest overview of the science involved in climate change at the moment, which is far from incomplete, far from complete, I should say. And yeah, thank you for watching. Bye bye bye.